Hey, it's Peter here again with AirHarp Industries. It's November 30th, 2010, and this is just a quick little video to kind of document where we're at and where we would like to be. As previously shown, this is the new AirHarp prototype. It's pretty cool, bordering on way cool, but there's some stuff about it that could be improved. First of all, the cost of the parts is not prohibitive, but it's pretty high, and it makes it a problem for us to get the parts to build the thing in any significant quantity, and it would definitely cut into any potential profit margin. A couple of the parts on this thing are kind of expensive. The Arduino Nano is like $35. The Maxbotics, what is it, LV Easy 4 is almost $30, like $27. And those are the two most expensive parts on this board, but they add up very quickly. So I mean, right there, that's $65, maybe $3 for this proto board. $1 each for most of these other components, a couple bucks for the piezo or something. We're looking at a $75 instrument here, just in terms of materials cost, and that doesn't account for all the time spent assembling this thing. So I really would like to bring the cost down so that you guys can enjoy these things and not have to spend an arm and a leg. So part of my idea here is, rather than use the rangefinder, the Maxbotics rangefinder, I'm going to try to make my own sonar system with this little ultrasonic transducer. So if I can get that working, these transducers are from SparkFun. They're about $5, $5.50, something like that. And if you look, that's basically what is on the Maxbotics module. It's just minus the board with the PIC microcontroller and all the cool timing circuitry and stuff. But I think I can replicate some of the electronics and programming that they use to make the sonar possible. I also want to try to get rid of the Nano, as much as I love the Nano. But it is a bit expensive. So one idea I had for that is these are Atmel ATmega 328 processors, just the naked processor. You can't use these directly. You have to, without some support hardware. So I'm going to try using these voltage regulators to get the supply voltage correct. Use these resonating ceramic resonators to 16 megahertz resonators to regulate the clock speed of the processor and stuff like that, and see if I can work with these things directly. There's also somewhere here an FTDI breakout board, also from SparkFun, that does like a serial UART, so you can plug it into your USB port and program it that way. Because the cool thing about the Nano is onboard USB, super easy to work with. But these things, there's no USB plug on this guy, so you gotta do a lot of this stuff yourself. So I've been kind of holding it off, but I think now is the time. Now is the time for me to step up to the plate and do some heavier engineering to make this thing a more viable product. Because ultimately, at some point, it has to become a product. It has to be something that someone's going to buy. And right now, this is a nice prototype, but it's not a product. It's just too expensive. There's wires on it. There shouldn't be wires. It should be on a printed circuit board. These should be traces on a printed circuit board. Other things like the buttons, they click when you press them. It's not insurmountable, but it's a little annoying. So I got these buttons over here, which are like silicone rubber, and they have a recess for an LED, so they'll light up. So I'm thinking of maybe putting some LEDs on the thing, and then have the buttons go over the LEDs, and then it'll be more visually interesting as well as not clicking. So that's about the size of it, and that's what I'm hoping to accomplish. One more thing, and this has been a thorn in my side, but the USB MIDI that this thing currently enjoys is made possible by a driver written by my friend and colleague, Michael Kurzaniak. The thing is, Michael Kurzaniak is a genius, and I'm not a genius, at least not in the way that he is. So I don't know how to write drivers for every operating system out there, and trying to figure out how to make a class-compliant MIDI controller is equally vexing for me. So it may so happen that we have to end up going the old-fashioned MIDI output route, and then if you want to plug it into your computer, you will just have to use a USB MIDI cable, adapter cable, which I have, but not everybody has one. The disadvantage to that is that right now this thing's running off USB power, so it's got power from the USB and it sends the MIDI data out via the USB. It's nice and elegant, but if we use old-fashioned MIDI, then you have to have a battery, which seems kind of redundant if you're plugging it into the computer, because the computer is a power source. But it might not be as redundant if you're plugging it into another synthesis system. I'm also going to try to do some more onboard synthesis. I'm going to experiment with that, and maybe we can make it possible to ditch the computer entirely and just make this a totally standalone instrument, which would be pretty cool. But anyway, that's where I'm at. That's what I'm working on. And if you guys have any suggestions, ideas, whatnot, please do send them my way, because I can use all the help I can get. All right, well, this is Peter for AirHarp Industries, signing off.